Hello. This time we have an exercise on subspaces. In order to start with this, we will consider a set of vectors in R2, collecting those whose product of the entries is greater or equal than 0. And then we're going to have to ask a series of questions. The first one, is this collection containing the 0 vector? Is the collection H closed under addition? Meaning, if I choose whichever two vectors in H and I add them, the result of that addition is also in A. And I want to know if multiplying any real number by a vector in H produces a vector is also in H. So meaning, is H closed under scalar multiplication? Okay, so let's start. To answer the first, well, the answer is yes, affirmatively. Why? You may say, well, look, in the vector 0, 0, right? If you take 0 times 0, that is 0, which is greater than 0. So 0, 0 is in H since its entries satisfy the condition defining H. That's a notion of set theory, right? In order to determine whether an element is in the set, we have to examine whether that element satisfies the condition under which the set is constructed. In this case, the entries, their product of the entries is greater or equal than 0, which indeed is the case for this. So, boom, we're done with this. Second, is H closed under addition? Well, that's a different story, because whenever you take two numbers, right, and you consider, well, look, when I multiply them and they have the same sign, they would produce a number that is greater or equal than 0, right? Keeping the instance about 0 kind of like a separate case. But we don't really have to worry about too much about it. So let me start like this. Note that the product of two numbers, real, with the same sign produces a non-negative number. But this doesn't mean that if we add two vectors in R2 whose entries have the same sign, this results in a vector with entries of the same sign. Right? Enough of the talk. Let's look at the example, right? That will make this answer this question being answered negatively. So I would say the vector 2, 7 is in H. You may say, why? Well, easy. If I take 2 times 7, that is 14, which is greater or equal than 0. But also, the vector -3, -2 is in H. Why? Same reason. I take negative 3 times negative 2, that is 6, which is greater or equal than 0. But we have that 2, 7 plus negative 3, negative 2 is equal to negative 1, 5, which is not in H. How do we know that? Well, take the products of the entry of this vector, which is negative 1 times 5. This is negative 5, which is not greater or equal than 0. Right? So what do we know from here? Well, H is not closed under addition. So that's a negative part. Okay, let's answer all the questions. And is H closed under scalar multiplication? Well, that's a different story, right? And for that, I'm going to start like this. What happens if I multiply a vector by a scalar? Well, that scalar is essentially distributed on each entry by multiplication. So when I multiply the entries on that newly generated vector, well, it would be the old product times the square of, well, whatever scalar we have. But the scalar of the square of any number, real, is greater or equal than 0. So if you multiply numbers that are already greater or equal than 0, you obtain numbers that are greater or equal than 0. Okay, let me formalize this argument. And I'm going to start like this. Let x and y be a member of H and S a scalar, so a real number. This symbol is to denote is in this collection. Right? This vector is in H. This number is real. Okay. Then we have that x times y is greater or equal than 0. And note that Sx times Sy is equal to S squared times xy, which is greater or equal than 0 times 0, which is greater or equal than 0. Why? Because the square of any real number is greater or equal than 0, and by assumption, we have that x times y is greater or equal than 0. And the product of such numbers is greater or equal than 0. So, S times xy, which is nothing else but Sx as y, is in H. So indeed, this space, well, this set is closed under scalar multiplication. However, we cannot say that H is a subspace of R2 because it's not closed under addition. For a set to be a subspace, it has to answer, well, you should be able to answer all these questions affirmatively. But as you can see, this one was negative. So, H is not a vector subspace of R2. And with this we finish. I hope that you like it. Take care.